This is brain in hand problem solving. Have your preview videos out. You should be looking at this. Please make note of both the location, the date and time they're watching this video. Don't forget to get a parent or teacher guardian sign off. I'd like you to take 3 minutes, and I'd like you to attempt to graph this problem. If you are done early, just fast forward the timer, but you have 3 minutes to attempt to graph the problem below. All right, let's take a close look. There are 2 ways to go about this. There's a couple ways to tackle this. One would be to use intercepts. Another would be to use y equals mx plus b. So first let's go through the intercepts. If we take here, we have 9x minus 3y equals 15. And for our intercepts, we do 0 blank, that gets us our y-intercept, and blank 0, that gets us our x-intercept. The easy way to do this, if you put a 0 in the x, it just says goodbye. Negative 3y equals 15, that's going to force the y-intercept to be negative 5. And then you could do the x-intercept, which if you put a 0 in the y, we say goodbye to that. And we're going to end up with 15 divided by 9, and 3 goes in there 5 times, and 3 goes in there 3 times. So we have 1 2/3 for our intercept. Don't be intimidated by that fraction. It's not that hard to graph. Or we change it to y equals mx plus b, which would be 9x minus 3y equals 15. Start by circling the y. Your goal is to get y all by its lonesome. So step 1, we're going to minus 9x both sides. We end up with negative 3y equals negative 9x plus 15. I switch these because I'm trying to get x into the first position so you'd recognize it. Again, our goal is to get y by itself. So we're going to divide by negative 3 every term to clear it. And our final is going to be y equals positive 3x minus 5. Now to graph this, I'm going to use y equals mx plus b, and I'm going to show you that those intercepts work just the same. So y equals mx plus b. Our b here is negative 5, so we're going to start right here at negative 5. And then our rise over our run, rise 3 over 1, and we know it's a positive line, so we have to slope upwards from left to right. So I'm going to rise 3, 1, 2, 3, and go over 1 to the right, so I have a positive slope. I could also go down 3, 1, 2, 3, and over to the left. I'm going to get the same results. And we graph that. Now just to check this with the intercepts, our intercepts here are going to be 0, negative 5 for the y-intercept. That's that one right there. That's 0, comma, negative 5. And our other intercept is 1 and 2/3 and 0. 1 and about 2/3, which is right there, just before 2. 1 and 2/3 and 0. So we can see y equals mx plus b and the intercepts does exactly the same thing. New material. We're going to be talking our key words today. Watch for these key words. The word neuron, frontal cortex, digital immigrant, digital negative, hypertext skimming, and linear reading. Several years ago, about mid-2005 or 6, I started noticing students, when I was a teacher working on a board, students would look at that board, and without picking up a pen, just looking straight at it, I would get this. I don't get it. Just looking at the board. And I started doing some research as to why was the initiative to interact by either tracing or drawing or writing on the board, something that would increase understanding. Why were students, it seems like they were less and less likely to do that, and the I don't get it reaction became increasingly frequent. And discovered something that because you students are digital natives means you were born and raised with the ubiquitous use of digital technology, that the amount of time that you used interacting with your physical fingers on things like tracing and drawing and writing on paper, not keyboarding, notice I said writing on paper, that all of these physical interactions decreased. Now, there's definitely many benefits of digital technology, but there are some interesting developments because of you growing up as digital natives. The first thing you need to understand that's really important is that the tips of your fingertips are connected to your frontal cortex. You have nerves that run through your fingertips that connect to, and your frontal cortex is the front part of your brain. the thinking part of your brain. So there's nerves running from your fingertips to the thinking part of your brain. Now, if anything I say right now seems really strange to you, you are welcome. I have references down below for you to look this up. So there is the science and the research behind about what I'm telling you right now. So step number one, the tips of your fingers connect to your frontal cortex. And the frontal cortex is the thinking part of your brain. Step number two, or thought number two, technology as a whole is reshaping our brain. Because our fingers are connected to our brain, technology is reshaping our brain. It's reshaping how we physically interact with our environment, in the sense that we are keyboarding more than we physically write. We are keyboarding more than we write. We click more than we physically color in diagrams. We tap on screens more than we touch physical models. Because all of these activities decrease fingertip usage in the sense of drawing and physically involving your environment. It is changing the way we process information quite drastically. So thought number two, digital technology is reshaping our brains. This is really critical that many of you may not have known before. Screen reading is different than print reading. And this is outlined in the book, What the Internet is Doing to Our Brains, called Into the Shallows. When you read on a screen, your eyeballs tend to hit the screen and go in hypertext mode. You tend to go fast. You tend to skim. It's just the way, because the electronic technology, versus when we are on paper, you do what's called linear reading, which is line by line, left to right, word by word. Now, is it possible to skim in print reading? Absolutely. But the default mode in print reading is linear reading, line by line, word by word. And then you tell yourself to go into skim when you need to. You're just quickly reviewing notes. When your eyeballs hit a computer screen, we tend to automatically go into skim modes, so it generally decreases comprehension. Thought number four, increase hand and finger usage increases brain function. So there's going to be some things I'm going to actually be asking you to do, things that maybe you're not used to doing on a consistent basis. Good mathematicians do these things automatically. Good studiers, if you will, do these things automatically. But many students do not, because of the way they grew up with technology. So there's things I'm going to be asking you to do with your fingers, with your hands, that are going to increase your brain function. And it's going to seem really simple at first, but you'll understand as you do this over and over again. Some key words you're going to hear, commands, is going to be when I tell you to trace things. I'm going to tell you to underline a lot. I'm going to tell you to do shading. Things that require physical use of hands on paper. That's going to increase brain function. I call this brain in hand problem solving. Take a look at this. You have this in your handout, in your folder. These are some buzzwords or phrases that will help you increase your brain function physically using your hands when interacting with math. Step number one is learning to finger track and read. That means whether you're looking at a screen or paper, you will put your finger physically on the screen or paper, and you will read and track left to right, word for word. That keeps your eyeballs from going into skimming. Then you will filter, which means to highlight or underline key words. When you're dealing with text, you do these four at the same time. Draw, label, list, cross out. I'll give you an example for that. When you're dealing with diagrams, one of the first things you should do is trace stuff. Just trace and sweep angles. Trace, that means to trace and sweep angles. You trace and mark things. You trace and stretch lines. You trace and shade stuff. You use your fingers to finger block and compare lengths. Again, look at all the buzzwords: tracing, shading, sweeping, blocking. You're going to do something what I call squeeze the sponge. Well, I'll explain in just a moment. You ask yourself, what can you do? You find everything that you can find. You don't ask the question, what should you do? When you use equations, I want you to write equations with two sides and an equal sign. I'll explain that in just a moment. And when you use equations, you're going to do what I call circle, plug, chug. And you box and label your answers. Before we actually use this, let's go ahead and cover a couple equations that I'd like you to remember. Very important. When you're working with equations, remember that all equations have two sides with a unequal sign. Two sides with an equal sign. So when you write equations, you're going to have an equal sign, and you're going to have something to the left and something to the right. If I ask you to write an equation and you put something just hanging there like this, that's not an equation, that's an expression. You'll get the hang of it in just a moment. There are two equations that you need to be familiar with to work today. One's called perimeter, and one's called area. Let's talk dimensions. We learned this last class. One dimension is when something is just length. Just length. And two dimensions is when something has length and width. So one dimension, just length. Two dimensions, length and width. Now, perimeter. I'd like you to put your pencil, please, right here. This is part of the brain and hand. Whenever you do perimeter, I would like you to physically trace your pencil around the object that you are working with to find the perimeter. So put your pencil there. Ready? Walk it around with me. All the way around. Put a little arrow to tell your brain that you went around. Okay, that's perimeter. When you're dealing with perimeter and rectangles, there's your length, there's your width. To find the perimeter, it's a trace and add. Trace and add. Trace, add. Say that with me out loud. Perimeter, trace, and add. So to find the perimeter, you see that you have one width, one length, two widths, two lengths. So I'd like you to write the equation like so. Perimeter equals two lengths plus two widths. Trace and add. Trace and add. That's perimeter. Trace and add. Area. When you deal with area, I'd always like you to get in the habit of shading areas that you're working with. Physically shade. So I'd like you to shade. It's like grass. Shade. And the cue for shade is shade and multiply. Shade and multiply. So we write the equation. Area equals, for a rectangle, length times the width. Length times width. So perimeter is going to be like a picket fence of a yard, the fence around the yard, versus area is the grass of the yard. That gives you a visualization. So when I talk about equations having two sides and an equal sign, I'd like you to do this with me. Perimeter. The equation for perimeter is not two lengths plus two widths. The equation is perimeter equals two lengths plus two widths. So when you write the equation for perimeter, I want P equals two lengths plus two widths. Equations have two sides with an equal sign. Area. Area equals length times width. So when you write this equation, I want two sides with an equal sign. Okay, I do not want, if I ask you to write area of a rectangle and you write this, that is not an equation, that's an expression. Okay, let's put some of what we just learned to practice. So whenever you get stuck, I don't know what to do. I'd like you to get this list out. You got it first day of school. It's colored. It's all colored and nice. I gave you a cover slip to protect it. I'd like you to get that sheet out, and I'd like you to go right down this list each and every time. That's going to help you learn to physically interact, pencil on paper, and help you get over that passive feeling, that paralyzing feeling, I don't get it, therefore I won't try. So when you don't know what to do, I'd like you to get this sheet out and start working top to bottom, all the way down. Okay. What I'm going to do right now is I'm just going to read this problem. I'd like you to put your pencil down, please. Pencil down. I don't want you to do anything with your pencil right now. Pencil down, please. Ready? Okay, I'm going to start here. I'm just going to read out loud. So just listen for a moment. Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width, and then doubled. Each bag of cement costs $6.50 and will cover 12.5 feet squared. The perimeter of the backyard is 64 feet. The tax on the subtotal is 10%. Find the total cost of the cement background. So as I read this problem, what's your first reaction? Just your very first gut reaction. Do you, when I read that, do you immediately say, oh, that's easy? Very easy. Do you think it's easy? Average? Did you get a little knot in your stomach, said, oh, that looks really hard? Or are you like, I'm not going to pick up my pencil? Why try? Okay, I'd like you to circle, honestly, what your first impression is. Be honest. Tell me, of these 5, what was your very first impression when you read this problem? Okay, now I'm going to help you using what's called the brain and hand problem solving techniques. We're going to do this problem together, so I do want you to pick up your pencil now. Ready. Step number 1 is to finger track and read out loud, which means we're going to read it again out loud with our pencils following every single word, and we're going to do what's called filtering, which means we're going to underline or use a highlighter, highlight all keywords, numbers, phrases, and especially units. But it's important you get in the habit of reading aloud with your finger or pencil on the paper. Ready? Put your pencil or finger right here. Okay? We're going to read. Track with your finger. Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width, then doubled. Each bag of cement costs $6.50 and will cover about 12.5 feet squared. The perimeter of the backyard is 64 feet. Tax on the subtotal is 10%. Find the total cost. Now we're going to filter. Okay, so check number 1. We finger tracked and read. Filter. It's a rectangle. The length of the backyard is 8 feet longer than the width, then doubled. Each bag of cement, so bag, costs $6.50 and covers about 12.5 feet squared. The perimeter of the backyard is 64 feet. Tax is 10%. I always like to box what I'm trying to find. What I'm ultimately trying to do is find the total cost. Okay, that's number 2, filter. That's called filtering. That helps your brain not be so overwhelmed with all the words. You narrow it down. Now we're going to do this very slowly all together. We are not solving yet. We're going to draw the problem, label it, list given information, and cross stuff out as we take care of it. So step number 1, we have a rectangle. So I draw a rectangle. And I'm going to cross that word out, rectangle. That tells my brain I've accounted for that. I don't need to deal with it anymore. The length of the backyard is, I emphasize that, is an equal sign. Watch out for is. Whenever you see is, stick an equal sign. It says the length is 8 feet longer than the width, then doubled. So we don't know the width, but the length is 8 feet longer than the width. So the width plus 8, then double. So then double. Cross that out. Each bag of cement costs $6.50. Now that doesn't go on the diagram, so that goes on what I call a list. So bag of cement costs $6.50. It costs $6.50 and covers each bag 12.5 feet squared. So each bag's going to cover 12.5 feet squared. Cross it out. The perimeter of the backyard is 64 feet. So perimeter, remember I told you to trace perimeter, so trace it. Ready, walk it around. That's perimeter, is 64 feet. So when you go all the way around here, it's 64 feet. Tax is 10%. That doesn't go on the diagram. I'm going to put it over here. Tax is 10%. Once you see percents, you should automatically turn it into a decimal so you can use it on your calculator. So you just go over twice. So tax is 0.10. Find the total cost. So our goal is cost. And box that, put a little question mark. That's our ultimate goal. Now, all of that, you actually haven't done any thinking or solving. You've just organized your given information. Okay, so we've traced around the edge. Now you ask yourself, it's very important, do not ask yourself, what should I do to do this? You ask yourself, well, what's really easy to find? What is really easy to find here? Well, it's really easy just to write out equations. That doesn't require any thought. And we have an equation here, perimeter. So what I'm going to do right here is I'm going to simply write out the equation for perimeter. Okay, now let's look what else we have. Once you have that equation, you see that the p's are the same. So that means that we're going to circle. This is called a circle, plug, chug. I circle the p there. I circle the 64. I draw a little arrow. That means I can replace 64 there. I'm going to do 64 equals. Problem is, I still have two variables. I have length and I have width. I can't work with that. But let's see what you can do. Circle this length. Now go up anywhere. Where do you see L? You see L up here. Oh, and there's an equal sign. Okay. Circle what L equals. Now come over here, connect it with an arrow, plunk that in. So we have 2W plus 8 times 2. That is the substitute for L plus 2W. Now we're down to one variable. So what can you do if you have one variable? Well, you can solve. So let's see what we can do to solve here. I'm going to start by distributing. So I have 64 equals 2W plus 16 plus 2W. I'm going to distribute this way. 64 equals, that's 4W plus 32 plus 2W. Now we continue to solve by collecting like terms. And we're going to take this 32 over. So now we have 32 equals 6W. We're going to divide by 6. Now wait a minute. 6 doesn't go into 32 evenly. Careful. Don't panic and don't assume you're wrong. Especially in real life problems, the vast majority of things that actually happen in real life do not come out to be whole numbers. So don't assume you're wrong just because you're getting decimals. 6 goes in there 5 times with 2 left over. That's 2 over 6. That's 5 1/3, which is approximately 5.33. Now, all that got us was what W was. So come up here, and W equals 5.33. 5.33. 5.33. Now we're going to add 5.33 plus 8. And we get 13.33. We times that by 2. And we get 26.66. So that is our length, is 26.66. Our goal is to get the cost. And we're going to be dealing with bags of cement that cover 12.5 square feet. So that's an area concept. So we need to find the area, which is length times width. Write that equation out. Always write the equation out. Yes, you probably learned that in 4th grade. Yes, you know it, but you'll still write it down. Ready? Now we circle, plug, chug. Circle length, circle the length, 26.66. Plug it in. Circle W, circle the W. Now I know here some of you are just about hyperventilating because you think I'm not going to let you use a calculator when you multiply with decimals. Yes, you may use a calculator. Let's go ahead and multiply that and get our area. We have length, 26.33, times the width, which is 5.33. So our area that we have to cover is 140.33 or 34 feet squared. Now it's really important that you get in the habit of labeling stuff here. So our area is 140.34, always get your units, that's feet squared. Now, our goal is to get cost, so let's look at what else we have to do. Each bag covers 12.5 feet squared. So to figure out how many bags, we're going to divide and see how many 12.5s go into that. So we have 140 divided by 12.5. And we get 11.22 bags. Now, warning, in real life, you cannot walk out of Home Depot or Orchard Supply with 0.22 of anything. So technically, you're going to be purchasing 12 bags. Now let's deal with cost. Let me get some space here. Hopefully you wrote a little bit smaller than I did. Just squeeze this anywhere you can on your paper. So for cost, we have 12 bags times $6.50 each. And that's $78. Now that's our subtotal, because there's this lovely thing called tax that you have to add on to that. And tax is 10%. So 10% of that, you just take that decimal to go 10% and you go 1 over. So we're going to go 78 plus 7.80, so $7.80. So now you add those, You get $85.8. That is your final and total cost. Always box and label your final answer. So we box, and then you just ask yourself realistically, does this sound realistic? Now, if you did your math wrong and you end up with something like $8,500 just to put in a cement patio, it's helpful just to kind of step back and say, hey, is this realistic? So what I'm going to do now is I'm going to put that 3-minute timer on again, and I'd like you to take a shot at this problem, and then I'll go over it. So you try this one on your own. Go. All right, let's see how far you got. You should have finger tracked in red, which means your finger should have been on the paper. Then you should have filtered, and filtering should look something like this. Miss Johnson wants to plant a flower marigold border around her small garden. The herb garden is rectangular, and the length of the garden is 3 times longer than the width. The area of the garden is 108 feet squared. It will take 2 pots of flowers per square foot to create the desired border around the garden. The flowers cost $3 per pot. How much will it cost to plant the marigold border? So we're doing this. Cost is our ultimate goal. So we just did filter. Now we do this together. We draw, label, list, cross out as a unit. Draw, label, list, cross out. So it's a rectangle. So I'm going to go ahead and draw another rectangle. Cross it out. The length of the garden is. Length is 3 times longer than the width. So I'm going to write length is 3 times longer than the width. Length is 3 times longer than the width. We have width here and width there. Cross it out. The area of the garden is 108 feet squared. So we shade for area, and area equals 108 feet squared. Cross it out. We're making a border, so we know for our marigold border, for every 1 foot, we want 2 pots of flowers. So I'm going to put a little notation here. For every 1 foot around the garden, I want 2 pots of flowers. That's my attempt of making flowers there. Cross that out. And the flowers cost $3 each. How much will it cost? So we ask ourselves what we can do, not should do. Always start with something really simple. For example, we are given the area here, so write out the area equation. Length times width. Now, once you write an equation out, you start doing circle, plug, chug. Let's see, circle A for area. We have A for area here. So we can circle that A area and we can plug it in. So I have 108 equals. Circle the L. Come up here, I have the L. Wait, I can substitute. So I have 3W times, circle W. There's our W times W. Now I'm down to one variable. So let's look at what we have. 108 equals 3, and then W times W is W squared, not 2W. You divide by 3. So I have W squared equals, and 3 goes in there 3 times with 1 left over. 3 goes into 18. 6 times. And now I have W squared. Now what I'm about to show you is incorrect, so don't write it down. This would be incorrect. See what I did there? That's incorrect, because to undo a square, you don't divide by 2. The backtracking of squaring is square rooting. So the opposite of squaring is square root. So we get W equals the square root of 36, which is 6. Are you done? Have you figured out the cost? No, but you can, again, circle, plug, chug. So we're going to take, oh, I've got W now, 6. I can come up here. That's 6. That's 6. That's 3 times 6. That's 18 and 18. Ready? Our goal is to get a border, so border means I have to find the perimeter, which I can do just by walking it around. So 6 plus 18 is 24, plus 6 plus 18 is another 24, so my perimeter is 48 feet. Am I done? Have I figured out the cost? No. But I have at least figured out how long my border is. And it says for every square foot, I want 2 pots. So I have 48 square feet. For every foot, 2 pots, so times by 2. Of course, that gets me 96 pots I'm buying. They're at $3 each. So we're going to go 3 times 96. Please get in the habit of doing single-digit multiplication longhand. It's good for the brain. It's good practice. 3 times 6 is 18. Carry the 1. 3 times 9 is 27, 28. So our total cost is $288.